Welcome. This is an introduction to probability. A probability experiment is an action, operation, or trial through which specific results can be obtained. Those results could be counts, measurements, or responses. A classic example of a probability experiment would be flipping a two-sided coin. Because of the symmetry of the coin, it's either going to land on heads or tails. If it lands on heads, then that's an example of an outcome. An outcome is the result of a single trial obtained from a probability experiment. There are three types of probability that we want to consider here. The first is called subjective probability. So subjective probabilities result from intuition, educated guesses, and estimates. Past data, which would be directly relevant to the situation, might be totally unavailable. And formal calculations aren't generally performed. So empirical and theoretical probabilities can't be calculated. Instead, the person's just trying to make their best guess of what the percentage or probability of an event occurring would be. I have an example here. It says, taking into account past experiences, as well as the age and overall health of a patient, a doctor might guess that a particular patient has a 95% chance of a full recovery after undergoing a particular type of heart valve replacement surgery. So here, the doctor has experience with the situation, and they're basing their probability on their past without using any hard data. So it's a bit arbitrary in nature, the number that they come up with, but it still has value. The next type of probability that we'll look at is empirical probability. So empirical probabilities are determined through actual experimentation. They can describe the results of past outcomes, and they're often used to predict the future outcomes. They would be used in situations where theoretical probabilities can't be calculated, and the relevant factors involved are often too complex to model or analyze completely theoretically. So, due to the dynamic and complex nature of our world, we should generally not assume that empirical probabilities calculated with past data will perfectly predict future outcomes. An empirical probability is generally only used as an estimate for future outcomes. Let's take a look at an example. In 2017, St. Louis had the highest murder rate in the US, with 205 victims out of a city population of 311,404 people. If you divide the 205 by the 311,404, you'll get a probability of 0.08% chance that a person in St. Louis died due to a crime of murder in 2017. Now, that past data could be used to predict that in the future, a St. Louis resident might have a 0.0658% chance of being a victim of murder. But should we assume that that is the correct probability for the future? The answer is, of course, no. Because there's so many factors that go into a murder rate, there could be, for example, different weapons policies, crime policies, changing demographics, and changing attitudes that would influence how many murders take place. There could also be just sheer randomness involved in the situation. So we cannot expect that the past outcomes will predict the future. So we cannot expect past data to perfectly predict it. Okay. The last type of probability that we'll look at is theoretical probability. So theoretical probabilities are also called classical probabilities, and they would be used when each outcome in a sample space is equally likely to occur. An example would be the flipping of a two-sided coin. Two-sided coin, by the symmetry of it, has a heads and a tails, which have an equal chance of landing up. And so, for that reason, we say that the chance of a fair coin landing on heads would be 50%. One of the things we'll look at here in the future, in a future video, is that a theoretical probability can be used to exactly predict what the cumulative results of ideal probability experiments would be over the long term. What does that mean? It's a little complicated. That means that if an ideal experiment were repeated an infinite number of times, then the theoretical probability would exactly predict the proportion of successes that would occur. Obviously, we can't perform an experiment an infinite number of times. So, it's theoretical in nature.